All right, number one, consider the following a tree diagram to display all the head tail sequences that can occur when you flip a coin 3 times. Okay, so when you have a head tail sequence, think about this. How many possibilities are there on a coin flip? Two. So each branch should have two possibilities because you either have heads or tails. So like for example, this isn't bad because this has three. You couldn't have heads and tails and something else. It's heads and tails, heads and tails, heads and tails. But why do we have three at the end? We're flipping a coin 3 times. So all branches should have two. So heads, tails, heads, tails, heads, tails, heads. So that would be good. Okay. Now, it might be good for me to draw this out a little bit, okay, to talk about the sequences. So I'm going to write this out a little bit here to better explain this. So I could have, I'm going to do it this way. So heads, tails, heads, tails, heads, tails, and then heads, tails, heads, tails, heads, tails, and then heads, tails. Okay. So looking at these outcomes, we've got heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So these are my all my possibilities there. So how many of these contain exactly two heads? So let's look. How many of these contain exactly two heads? There's one, there's two, there's three. So we have three that contain exactly two heads. So a little bit of a probability extension here. We did this in the notes. Assuming the sequences are equally likely, we have a fair coin. What's the probability that you'll have exactly two heads? So I have three of them have exactly two heads out of the outcomes. And these are all equally likely out of how many possible outcomes? 2, 3, 4, 5, 6, 7, 8. So it'd be 3 divided by 8. And we want to do this as a decimal. So 3 divided by 8. 0.375. Okay. And so probably get exactly two heads. Okay. Now comes the little bit stressful part. We've um, got to figure out what counting principle we're going to use here. There are 9 wires which need to be attached to the circuit board. A robot device will attach the wires. The wires can be attached in any order, and the production manager wishes to determine which order will be the fastest for the robot to use. Using the multiplication rule of counting, determine which number of possible sequences that must be tested. There's 9 choices for the first wire, 8 for the second, 7 for the third. So let's think about our notes. The multiplication counting principle, we use that here. If there's 9 for the first one, 8 for the second one, all that. What's a simplified way to find the answer here? What should I do if there's 9 possibilities? 9 factorial. So you could use your calculator. I'm going to go shout out Desmos here. I'm going to show you how to do it in Desmos if you want another way. Okay, this might not be time efficient. Okay. Maybe I should have had this loaded beforehand. Desmos is taking a while to load. 9, and then you go to math, PRB 4. So 362,880. Okay, we might have to. I just wanted to give Desmos a shot there. Having trouble loading. Okay. So I've got quite a bit there. All right. Desmos loaded real quickly. It's still loading. All right, we'll come back to that. Compute P54. Very straightforward. In your calculator, you can do this very simple. Got a math, PROB, MPR, 54. So it's MPR 54. Okay. So 120. So math, PROB, option 2. If this will load, I can go to math tools. I can go to this statistics calculator. No, I'll go to scientific calculator. Okay, go to scientific calculator. So it might take a while to load there. This is taking a while to load. So 120. So combination 7-2. So you got a math, PROB, NCR, 7-2. So 21. So that's a combination of to select. How can I select? I have 7 items. How can I select 2 of them? How many combinations of 2 can I select out of 7? I was going to see the statistics menu here. I could be taking us down the. Okay. There, yeah, it's down here. You could use NPR, NCR, all that. That's on there. It's like 9 factorial, NCR, 7,2. Okay, so you could use Desmos on this as well. So that's just kind of showing you. You have to go to click function, and then just those are your options there, and then the exclamation point. So if you're ever in a spot, you need a. All right, let's look at the next one. There are 3 nursing positions to be filled at Lilly Hospital. Position 1 is a day nursing supervisor. Position 2 is a night nursing supervisor. Position 3 is a nursing coordinator position. There's 15 candidates for all 3 positions. Determine the different ways they can be filled. So the question we have to ask ourselves first, does the order matter in which they're selected? Let's think about this. Is there a difference between the people that are selected? Position 1, position 2, position 3. Will there be a difference between the people that are selected, like in terms of what position they would have? Will there be a difference? Position 1 is a day nursing. Position 2 is a night nursing. Position 3 is a nursing coordinator. These are different specific orders. So what we need to do is the order does matter because it matters if you're selected first, second, or third. It matters because you'll have a different position depending on how you're doing it. So if order matters, we're going to use a permutation. If order matters, we're going to use a permutation. PROB, math, PROB, NPR. How many possible nurses do I have? I have 15 candidates, so that'd be my N. And then my R is how many I'm selecting. I have 3 positions, so it'd be 3 positions. It'd be 2,730. Okay, so order does matter there because because it does matter whether you're, which position you get that matters and what you are. There's 11 qualified applicants for 7 trainee positions in a fast food management program. How many different groups of trainees can be selected? So now let's think about the 7 people that are being selected. Does the order matter with them? Or is there a difference between the positions from one position to another? Like from trainee position number 1, trainee position number 6, is there a difference? No, there's not a difference. You see out here, there was a difference. One's a day, one's a night, one's a night nursing coordinator. This one order does not matter because there's not a difference between the positions. So this one, we're going to use a combination. So you have 11 applicants, 7 spots, 330. Okay. Once again, if you don't have you do Desmos, NCR. Okay, 11,7. We did permutation earlier. NPR 15.3. So you could also use Desmos as well. Okay, and I'll give you the answers as well. All right, loading a little slow this morning. 7, there's 9 balls in an urn. Okay, they're identical except for color. 3 are red, 5 are blue, and 1 are yellow. You want to draw a ball from the urn and know its color and set it aside. You take another ball, know its color, make a tree diagram. Sometimes it helps me to actually visualize this. There's 9 balls in the urn, and there's identical except for color. There's 3 that are red, 5 that are blue, 1 that are yellow. So I've got 3 possibilities. Okay, so I'm going to draw this out. There's 3 red, so red. I've got 5 blue and 1 yellow. So I've got 3 red, so that would be 3 out of 9. 5 blue, so 5 out of 9, and yellow would be 1 out of 9. Okay, so that we start with 3. Okay, now next we're going to go look at the red one. If I select a red one, how many possible balls could I select for the next one? What possibilities are there? Red, blue, yellow. So if I select a red one, All right, let me go ahead and write this out. If I select a red one, that means I have 8 left and 2 of them are red. Okay, because I take away 1 from the red. If I select a red one, that means I have 8 left and 5 of them would be blue because I didn't select the blue one. If I do one that's red, I have 8 left and 1 of them's yellow. Okay, there's your, so there'll be 3 outcomes. Blue, if I do a blue one, I can get red, blue, yellow here. So red, blue, yellow. I'll just go ahead and spell it out. All right, so if I get a blue one, 5 out of 9, there's going to be 8 left. How many of them are red? Well, there's 3 red. So 3 out of 8 would be red. There's 8 left that are 8 left. 4 of them are blue because I took away 1. And then yellow, 1 out of 8. Whoops, 1 out of 8. Okay. Now here's the trick. What if I select a yellow one? What options are there left? Well, I could have a red one. I could have a blue one, but think about this. There's one yellow one, but if I select the yellow one first, could I select the yellow one the second time? No. So there's no third branch on this one. Red would be, there'd be 3 out of 8. Blue, 5 out of 8, because there's 5 blue and there's 8 left. So that gives you your probability, or that gives you your little table there. So one of these branches, we're going to have a 3 and then 3, 3, 2. This is what we're looking for because one of them, the yellow one, you can only do red or blue the second time. Okay, this is the kind of the most stressful part. You're going to have different numbers than me. Compute the probabilities of X, Y of the order ball. So RR would be red, red. So for RR, so P of RR, what I do is I multiply these outcomes of the branches. 3 out of 9 times 2 out of 8. Okay. So 3 out of 9 times 2 out of 8. 3 times 2 is 6. 9 times 8, 72. So it's 6 divided by 72. Now, can you leave it like that? You should be able to leave it as an unreduced fraction. If I get in trouble here, it'll be fine. I'll just go back and fix it. Red, blue would be 3 out of 9 times 5 out of 8. Because you got 3 here. Move this over here. So 3 out of 9 here times 5 out of 8 there. So that's 15 over 72. So 15 over 72. Okay. Red, yellow. Red, yellow is 3 out of 9 times 1 out of 8. So it'd be 3 over 72. 3 divided by 72. Blue, red. And you could do this without doing the tree diagram. You do it in your head, but tree diagram helps. 5 out of 9 times 3 out of 8. Denominator is going to be 72 every time, and that'd be 15 divided by 72. Okay. Blue, blue. So 5 out of 9 times 4 out of 8. 5 out of 9 times 4 out of 8. That's 20 divided by 72. Divided by 72. Blue, yellow. Blue, yellow. 5 out of 9 times 1 out of 8. That would be 5. 1 times 5 is 5, 72. So 5 over 72. Okay. Yellow, red. P of yellow, red. 1 out of 9 times 3 out of 8. So it'd be 1 times 3 is 3. And then over 72. And then yellow, blue. And that's going to be 1 out of 9 times 5 out of 8. Okay, which would be 1 times 5 is 5 over 72. Okay. Okay, let's see. That's a lot of work there. I didn't mean to select that one. It was already selected wrong there. Okay, this is the right answer. So sorry, I did not mean to do that. All right, let's go to the next one. A sales representative must visit 8 cities. There's direct air connections between each of the cities. Use the multiplication rule of counting. We've already encountered this. The multiplication rule of counting. So if we look at the multiplication rule of counting, we did that on number one of these previously. Okay, number 2, the multiplication rule of counting, and there's 8 possible cities that they could go to. How do I tell the number of choices? So what's the strategy here? This, if it's multiplication rule of counting, you just do that number factorial. So 8 factorial. Okay. Because it's like 8 times 7. The multiplication rule of counting, you're just doing the factorial. You're doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. You could also do Desmos on this. 8 factorial. Whoops, I didn't mean to do that. 8 factorial. So, all right. It's taking a while to load. Number 9, the University of Montana ski team has 9 entrants in the men's downhill ski event. Coach would like a first, second, and third places to go to the team members. How many ways could 9 team members achieve first, second, third? So I'm selecting a few from a whole, and I've got to think. The people I'm selecting, does the order in which they are selected matter? Is there a difference between the people that are selected? Yes, first, second, third. So this order does matter. So this is a permutation. So it's math, PRB, NPR, 9 people, and then for 3 spots because it's first, second, or third. So it'd be 504. As I said, you could do this on Desmos as well. Move this over. NPR 9, 3. Okay. All right. Lastly, number 10, during the computer day special promotion at customer service, purchasing a computer and a printer is given a choice of 3 free software packages. There's 11 different software packages. How many different groups can be selected? So think I'm selecting a few from a whole, so 3 out of 11. Does it matter? Is there a difference between the 3 software packages? No, so does order matter here? So order does not matter what I use. Combination, good job. A combination. So 165. Right. Said you could do that here. NCR 11.3. All right. It's taking a while to load. There you go.